Okay, so we're going to do section 1.3 today, and that's going to be revolving around the distance and midpoint formulas. We're going to spend the majority of the class talking about a midpoint. All right? Well, a midpoint is exactly what it sounds like it is. It's the middle point of a segment. All right? So it says that it divides a segment into two congruent segments. What does congruent mean? They have the same measure, right? So a midpoint is the point directly in the center of a segment that makes two equal segments on either side of it. Okay? So another thing we have is something called a segment bisector. Now, anytime in geometry class, if you hear me say the word bisector, it's going to divide something exactly in one half. Okay? It's going to divide it exactly in half and make two equal parts. So we have segment bisectors, we have angle bisectors, we have circle bisectors, we have just about anything that we can talk about, we have a bisector for. Okay? So a bisector divides anything exactly in half. So a segment bisector is going to cut through the midpoint. Okay? A bisector can be a line, it can be a ray, it can be anything that goes through the midpoint of a segment. All right? So here's some figures. All right, so the first one is just a segment AB, and it has M is the midpoint. Now, if they did not tell me M is the midpoint, I could tell by the picture because of these little marks right here. Okay? I told you guys yesterday, if a segment has the same amount of little tick marks, that means what? They're congruent pieces. So these little red marks right here tell me that segment AM is congruent to segment MB. Okay, so by definition, I would know that point M is the midpoint of that segment. Okay, so that's just a picture of what a midpoint looks like. This picture is really similar, except for it doesn't just have a point in the middle. It has a line cutting through the middle. Okay, so again, it's showing me that AM is congruent to MB with those little tick marks. So we know M is the midpoint. Therefore, that line is the segment bisector because it's where the midpoint is. It cuts through it at the midpoint. Does that make sense? So M is the midpoint. The point is directly in the middle. The bisector is where it cuts through the midpoint. Okay? All right. I'm going to skip that example. That's an example of a skateboard in the book. I'm going to skip it. Is that okay with y'all? Y'all okay with skipping things? All right. Let's work some problems. Oh, y'all can't see all that. I'll scroll it back up. All right, so they give me a picture of a segment VW, and they tell me that M is the midpoint of segment VW. And they tell me some measures of VM and MW. VM's measure is 4x minus 1, and MW's measure is 3x plus 3. And they want me to find the exact length of segment VM. So I got three segments, basically. I got the whole segment, and then I got the two smaller segments, which are half of the big segment, right? And I don't know the measure of any of them. Not exactly, because I have variables. Can anybody look at this and maybe take a guess on how we're going to figure these things out? Yeah, tell me.
Add the exponent and just have it.
Add them up to what, though? Why would I add them? What do you think? How would I don't have an equation. So how would I get an equation? I don't have an equation. You make an equation. How do I make an equation? Yep. But what do I know about them? They're the same. What's another word for the same? Equal. All right. Good job. So, I'm just trying to get y'all thinking with terms, right? Okay, so I know that this segment is congruent to this segment, right? That means whatever the measure of this segment is also the same measure of this one, right? They're equal measures. So that means no matter what x is, I can set this equal to this, correct? So that's what we're going to do to figure out what x is. Y'all were telling me the right things, y'all just didn't get me there yet, okay? So I'm going to say 4x minus 1 equals 3x plus 3. Okay? So midpoint means I have two equal pieces. So if we have variables, we can set them equal to each other. Now, y'all, solving equations 101. You've done it since like 6th, 7th grade. I just taught it to some brand new Algebra 1 babies this week. Okay, when we're solving for x, we want to first get my x's together if we have on opposite sides of the equal sign, right? Right? So I want to move one of the x's to the other side. Can somebody tell me how I could do that? Yeah, you can subtract 4x on both sides, or you can subtract 3x on both sides. I kind of like to keep my math positive, so I'm going to subtract 3x on both sides. And what is 4x minus 3x? It's what? 1x. Good. So x minus 1 equals 3. Then what? Add 1 everywhere, and x equals? What's 3 plus 1? 4. X equals 4. Did they ask me what x equals, though? No, y'all have got to read the problem. Because if you stop right there, that's wrong. Okay? The problem says find the length of segment VM. Yes, ma'am. Yeah, that's all I got to do is plug 4 in for x. So it's going to be 4 times 4 minus 1. I'll scroll up so I have space. What's 4 times 4? What's 16 minus 1? 15. So the length of VM would be just VM equals 15. Now that's my answer. Could I check it? How could I check it? The other one should also be 15, shouldn't it? What's 4 times 3? What's 12 plus 3? 15. So it's 15 on both sides. So that's correct then. Y'all with me? What if instead of asking me for the length of VM, they asked me for the length of VW? What would the answer be? 15 plus 15 is 30, right? You double it. So if they're asking for the little one, you're going to get half of the big one. If they ask for the big one, you double one of the little ones. Does that make sense? All right, any questions? All right, this next example is the same thing. Same thing. They tell me that S is a midpoint, and the picture also shows that S is the midpoint because I have two congruent segments here. And it wants me to find the length of ST, which is another one of the short segments. So before I can find ST, I have to solve for X, right? And to solve for X, I need an equation. So how do I set up my equation, y'all? 5x minus 2 equals 3x plus 8. So how can I solve this for x now? Subtract 3x. What's 5x minus 3x? So 2x minus 2 equals 8. Then I'm going to add 2 everywhere. Yep, so 2x equals 10. Divide by 2, and x equals 5. Can I stop there? No, they asked me to find the length of what? ST. So when they say find ST, that means find the length of ST because there's nothing above it. And remember we said yesterday, if it's just two letters beside each other, it means the length of that segment or the measure of that segment. So ST is going to be, plug it in here, 3 times 5 plus 8. Does that make sense? ST is 3x plus 8, so I know x is 5. What is 3 times 5? Plus 8 is what? 23. So the length of ST is 23. How can I check it? Plug in x on the other side and make sure you get 23 again. 5 times 5 is minus 2. Is that 23? Yep. What if they want the length of RT? What would that be? 46. Very good. And I'm asking you that because you're going to have some on your assignment that is going to ask for the long segment. Okay? So then you just plug it into one and you can double it. Right? Or you can plug it into both and add them together, whichever way works for you. You guys try this one. You don't have to open your book to page 19. The picture's right in front of you. So M is the midpoint. X plus 5 is the length of AM. 2x is the length of MC. Try to find the length of AM for me. We've got to dust some of those algebra cobwebs off our brain. It's been a while, hasn't it? And it's really been a while since y'all saw equations. All right, once you get what you think is the length of AM, check it with somebody. If y'all didn't get the same thing, y'all discuss it. Can't both be right if you got something different. Okay, so how do we set this up to solve it, y'all? All right, before I can find the length of AM, I have to find x. So I make an equation, x plus 5 equals 2x. Then how do you solve for x? Get your x's together. Not in real life, because that would be a bad party. Okay? But in algebra, we like to get our x's together. So what is 2x minus 1x? Just x. So there it's solved. X equals 5. Y'all get x equals 5? But what did it ask me to find the length of? AM. And AM is x plus 5. And now that I know that x equals 5, so I have 5 plus 5. So the length of AM equals 10. And you can check it. What's the length of MC? 10. It's also 10. 2 times 5 is also 10. So raise your hand if you got the length of AM is 10. Are there any questions? Anybody? We good? What if it asks me what's the length of AC? It's 20. You double 10. Not my problem. Okay, let's talk about midpoints. How to find a midpoint. Okay? Midpoint formula. It's on my screen and it'll be on your paper. Unless I tell you you don't have to write it. You need to memorize this formula. You need to memorize this formula. You see that formula? You need to memorize that.
Yes, ma'am.
You're going to have to memorize a lot of stuff in here. Study and game has to be on point.
I've never studied, ever, and I've never felt that.
Welcome to geometry. I had honors kids last semester that had to study. Okay, so this is talking about the midpoint of a segment that actually has x and y coordinates. Okay, so we have an x coordinate and a y coordinate for 2 points. And we want to find the point that is at the midpoint, halfway through the middle of that segment. Okay? So they're going to give me 2 ordered pairs for 2 points. Those are the ends of the segment. You're going to find the ordered pair that's going to be directly in the middle of that segment. Okay? You don't have to graph them. We're going to do it algebraically. All right. Let's turn it around. So, basically when you're finding the midpoint of 2 ordered pairs, you're basically finding the average of the coordinates, the average of the x coordinate and the average of the y. Okay? So let's just go over some basic things real quick about 1 and 2. Don't let that confuse you. When you have a midpoint, you're going to get an ordered pair. That's why we have parentheses and that's why we have a comma in the formula. All right? So, your answer is going to have parentheses and a comma. It's going to be 2 numbers. It's going to be an ordered pair. Now, when you're talking about 1s and 2s and stuff, y'all know that every ordered pair has an x and then a y, correct? Every ordered pair has an x and a y. They're alphabetical order. Okay? Now, if they're in the first ordered pair, those are the 1s. If they're in the second ordered pair, they're the 2s. Does that make sense? First ordered pairs are the 1s. Second ordered pairs are the 2s. Okay? So, if I want to find the midpoint that is halfway between these 2 points on this segment, I'm going to add the x's and divide by 2 and add the y's and divide by 2. That's what you do. Add the x's, divide by 2, add the y's, divide by 2. So, what is my x1 number? 1 plus, what's my x2 number? 4, and I'm going to divide that by 2. Okay? Comma. What's my y1? What's y2? I'm going to divide that by 2. Well, this one's not very pretty, because what is 1 plus 4? And what's negative 3 plus 2? Negative 1, right? So this ordered pair is 5, 2 goes into 5, 2.5, so it's 2.5, comma, negative 1.5. Right? That's it. You add, divide by 2, and add, divide by 2. X is divide by 2, add your y is divide by 2. Yes, sir.
Do we need to make them like improper fractions?
Yes, that works out based in algebra. However, if you're talking about points on a graph, and I'm graphing a point, it makes more sense to graph it at 2.5 than 5 over 2. Right? Because if you're on a grid, you're counting off 2 and then a half spaces. Does that make sense? So, yeah, for points, I usually like mixed numbers better. But you're right, most math teachers like improper fractions better, and there will be times where I want you to give me improper fractions. But if we're talking about graphs, you want to probably keep it a mixed number. No. No, because honestly, I prefer them. Because I'm a weird math teacher. All right, same thing right here. I have the endpoints of a segment GH, and they tell me G's coordinates and H's coordinates, and we want to find the midpoint of that line. Okay? So again, if it helps you, label your coordinates. This is an X, this is a Y, this is an X, this is a Y. These are my 1s, these are my 2s. Okay? So I'm going to plug them in the same formula. X1 plus X2, divide it by 2 to get my X. Y1 plus Y2, divide by 2 to get my Y. Okay? So what is X1? 7. Plus, what's my X2? Negative 5. I'm going to divide that by 2 in a second. And what's my Y1? Negative 2. Plus, what's my Y2? Negative 6. And I'm going to divide that by 2. And put parentheses around it because it's an ordered pair. And ordered pairs have to have parentheses. All right, I'm just going to simplify it a little bit above it. So what is 7 plus negative 5? 2. And go ahead and tell me what's 2 divided by 2. So the X coordinate of my midpoint is 1. And what is negative 2 plus negative 6? And what is negative 8 divided by 2? Negative 4. So 1 negative 4 is my midpoint for that segment. I like it better when it comes out to be whole numbers, don't y'all? Makes me think I'm doing it right. Right? So it's really not that bad, is it? Add your x's, divide by 2, add your y's, divide by 2, and then you'll have an x and y. Okay? You guys try this one. Find the midpoint of segment AB. Here they are. I'll highlight them. It's kind of hard to see with all that stuff on my board. When you get your ordered pair, check it with a neighbor. Remember, it should have parentheses around it. Okay, I'm writing my formula. Y'all please tell me how to plug it in. What's X1? What's X2? And I'll divide that by 2. And what is Y1? What is Y2? And divide that by 2. What's 1 plus 7? And what's 8 divided by 2? Oh, Lord. What's 8 divided by 2 again? 4. Yeah, I saw what y'all are doing over there. What's 2 plus 8? That one's 10. Come on, pen. And what is 10 divided by 2? 5. Raise your hand if you got 4 or 5 for your ordered pair. Awesome. So, y'all, that's seriously all you have to do to find a midpoint. Add the 2 x's divided by 2. Add the 2 y's divided by 2. All right. I'm skipping all this stuff. Aren't y'all glad? Okay. Now this might be a little bit more complicated. However, you probably did this in Algebra 1.
Are all these going to be on the same test?
Yes. Yes. It's in Chapter 1. But we probably won't see a test till the middle of next week because I told you I'm not going to do a quiz. So we'll see it on a test in the middle of next week. So we'll have plenty of time to practice it between now and then. And yes, we need to memorize this formula. It's a big, long one. But yeah, we should have seen this one in Algebra 1. Now, we've already went over like X1 and Y1 and X2 and Y2 and what those are and where they come from, right? Okay, so anytime they ask you to find a length of a segment, that's how long the segment is between two ordered pairs, you can define it using something called the distance formula. D equals big radical parentheses x2 minus x1 parentheses squared plus parentheses y2 minus y1 parentheses squared. Yes, I have it memorized, and yes, you can too. Because y'all have young brains, and I have an old one. Okay? So, what's the length of a segment RS with the endpoints R of 2, 3, and S is 4, -1? So, write down those two ordered pairs for me. So I'm going to go ahead and label my coordinates. I have an X and a Y and an X and a Y. My first ones are 1s. My second ones are 2s. Okay? So this is why we might need our calculator today. Just in case. Now don't overly use your calculator because I'm going to show you how your calculator lies to you in just a second. So I'm going to plug that into that formula. D equals big radical x2 minus x1 parentheses squared plus parentheses y2 minus y1 parentheses squared. And you might be thinking, am I going to have to write that formula every single time? And I'm going to say yes until you memorize it. Okay? Because sometimes writing formulas down help us to memorize it. The more we use it, the more we see it, the more we can learn it. If you write it at like the top of your problems that have to start doing this too, I'm okay with that. Okay? If you just write it one time and refer back to it every time, that's fine. Okay? So we're going to plug in. What do you think D stands for? The distance between those points. So I'm going to leave D alone. Equals big, huge radical. Y'all know radical is another word for square root, right? Now, I'm going to keep that big radical all the way through my problem, and the last thing I'm going to do is take a square root. Okay? So, parentheses, what number is my x2 number? 4. Minus what is x1? 2. Plus parentheses and put a square. Plus parentheses, what's my y2 number? -1 minus 3, parentheses, squared. The first thing I have to do, according to the order of operations, is what? Parentheses, right? So D equals big radical. That thing's just hanging on there. What is 4 minus 2? So I have 2 squared. Plus, what's -1 minus 3? -4 squared. Then I do my exponent, right? So 2 squared is 4. What's -4 squared? Positive 16 or -16? My calculator says it's -16. But if I say -4 squared in my calculator, it tells me it's -16. A calculator can't be wrong. Did you use parentheses? That's why. Okay. If you want your calculator to do that right, you got to use parentheses, okay? So your calculator is only as smart as you are, to be honest about it. All right? You got to know a negative squared is a positive. Because a negative times a negative is a positive. We've learned that since we were young, right? Well, since y'all were like 12 and 13. Right? You learned that. Okay? So don't be too dependent on your calculator. You should know that's positive 16. Now, what's 4 plus 16? 20. So D equals the square root of 20. Now, y'all, there's an actual answer for the square root of 20, and there's an approximated answer for the square root of 20. Okay? So in Algebra 1, we taught you to do something called simplifying radicals. I know Miss Hayes taught it, and I know Miss Bishop taught it, and I know I taught it, so there's no excuse. Okay? So, to simplify a square root, you think of the largest square number that goes into that number. So what is the largest square that goes into 20? 4. So change that to the square root of 4 times 5, correct? And what is the square root of 4? 2. Pull that outside. So D, the distance is 2 radical 5. Okay? So if they're asking for an exact answer, that's the answer, 2 radical 5. If they will allow you to round the answer to however many decimal places, do y'all know how to type a square root in your calculator? Or I'll tell you how to do it on my big calculators. Let me show you. Time out. Let me clear it out. Okay. So yours looks similar to mine, but it's not the same colors, and I understand that, but the buttons are in the same spot. The square root button is diagonal from the 7. You see the x squared? And then I think yours is yellow or green or some other color. It has a little square root sign. Okay? To get that little one, you kind of hit like the second button. The second button on these big fancy calculators is like a shift key on a keyboard. So you hit second x squared, and it should put a square root in there. So we're going to need that button a lot. So second x squared, and you can just type it in the square root of 20, and it should tell you it's 4 point something. Right? So if it tells you to round it to, let's say, 2 decimal places, that would be approximately 4.47. Now, y'all, if you're rounding a square root, do not say equals. It does not equal 4.47. It does not equal 4.5. It's approximately. We round it. So when you're going to round, you need to put these little squiggle marks. Okay? When you round, you need to put squiggle marks. You only say equals if it's exact. Got it? Your buttons might not be working. I'll look at it later. You don't need parentheses. No, I did not. I did them in my head. I wrote down all my steps. I didn't use them in the calculator. Oh, you talking about when the square root popped up? So if you wanted to close that. Okay, then you hit the above the 9. See that? You don't have to even close it though. Yeah. All right, let's try another one. Now, all of your homework says you can round it to the nearest tenth. That means this could have been 4.5. Does that make sense? So it's just whatever the directions of what you're doing says to do. All right, y'all write down these ordered pairs. We're going to try another one. 2 and okay, that row. Yeah. All right, distance formula. D equals big radical, parentheses, x2 minus x1, parentheses squared, plus parentheses, y2 minus y1, parentheses squared. Okay? So here's x1, here's y1, here's x2, here's y2. If you can do it without labeling your coordinates, that's okay. I'm just making sure that we can all understand that, okay? So I'm going to plug them in. D equals big radical sign, parentheses. What is x2? Y'all tell me. -4 minus what's x1? 2, parentheses squared, plus parentheses, what's y2? 8, minus what is y1? 5, parentheses squared. Then we do our parentheses. What is -4 minus 2? So that one is -6 squared. Plus what is 8 minus 5? 3. So 3 squared. So D equals radical, what's -6 squared? Positive 36. And remember, a negative squared is always positive. Plus, what is 3 squared? 9. And then we add them. What's 36 plus 9? 45. And what's the square root of 45 in your calculator? Approximately what number? Should be 6 point something. 6.70. Did y'all get the same thing? All right. Now see my squiggles? We rounded, so we squiggle it. All right. I want you guys to try this one. And then we're going to check it and see if we all get the same thing. So use the distance formula to find the length of a segment AB. And this will be our last one we do today. You may round your answer when you're done. Yeah, that'll be fine. Because the homework will say nearest 10. If you have an answer rounded already, you can check it with somebody else who's also done. Don't bother somebody that's still working, please. All right, everybody look up here. Because I'm hearing lots of different answers. And it's probably due to us, like, missing a sign somewhere when we're adding and subtracting. Honestly, that's usually what happens on these. So, I don't even know what the answer is. I ain't worked this in about a minute. So, what's my x2 number? 1 minus what's x1? All right, y'all. What does minus and negative mean? You add them. Okay, just checking. Plus, what's y2? Minus y1. 2 squared. Okay, so say we're going to add that. So what is 1 minus negative 3? 1 plus 3, which is 4. So that is 4 squared. A little longer. What's negative 4 minus 2? Negative 6 squared. So D equals the square root of what's 4 squared. Plus what's negative 6 squared? 36. 16 plus 36. So the square root of 52. And if I round that, that's approximately what? 7.2-ish. Did y'all get something close to 7.2? Raise your hand if you did. Y'all did awesome. So again, be real careful because if you missed the sign right here, that would have kind of made y'all to get something different. Now, how are we going to get good, y'all? Practice. So anytime it says find the length of a segment, you're going to do distance formula. Well, here's our practice for tonight. I'm going to stop recording so that YouTube land does not hear y'all whining. My class is whining, so goodbye.